Up until this point, we've seen ionic bonding, where anions and cations come together because they are attracted to each other because of their opposite charges. So for instance, sodium chloride, we have a positive charge attracting to a negative charge. But as you well may assume, there are many, many molecules that exist that are not ionically bonded. They are not salts. These molecules are forming what are known as covalent bonds, in which neutral atoms share electrons between them. A great example of this is water. These are both nonmetals, and they are bound together because they are sharing electrons. So they both brought their electrons to the table, and they are sharing them. Lewis dot structures are models for electron sharing. They help us to visualize what electrons are being shared between what atoms. For Lewis dot structures, we'll do what's called the table filling method. Let's assume that we have an oxygen atom, and it's got a table around it. On each side of the table, 2 people can sit, much like the tables out in the quad. 2 people can sit on each side. First thing that we need to do is figure out how many people are sitting around this oxygen table. To do that, you'll need to reference your periodic table. To figure out how many people are sitting around the table, we'll need to know what's called the valence electrons. That's how many electrons are on the outer ring of an atom. The electrons on the outer ring of an atom are the ones that will form bonds with other atoms. So if we look at oxygen, we can figure out the valence electrons by looking at the Roman numeral of the column. So we have column number 1 over here, 1, 2, and then it goes over here, 3, 4, 5, 6, 7, 8. 8 being the most that can fit around that table. So if there's 8, it's full. Oxygen has 6 electrons that are sitting around its table. So we're going to put our 6 electrons out. Much like how humans would fill a table, electrons only want to have one electron per side if possible. Same with people. You don't want to sit next to someone, you want all the room on your side of the bench. So everyone's going to sit around on their own benches first, and then when additional people come, they're going to fill in the table. So we'll start with that. So we'll start on one side, 1, and I like to go around in a clockwise fashion, 2, 3, 4. Now we've got my 4 electrons around the table, but I have 6 to fill, so now I have to start putting them on the same side of the table. 5, 6. So we notice here that there is room for 2 seats at the tables. This is where oxygen is going to share electrons to make that happen. So let's look at the assignment. So for number 1, we have H2S, which is hydrogen sulfide. On the periodic table, if we look for sulfur, it's got 6 electrons. Those are represented by dots. 1, 2, 3, 4, 5, 6. And hydrogen each has 1 electron, and those are represented by X's. And we can see here that each of those 1 electrons fits nicely into the open space for sulfur, giving sulfur a full table. Hydrogen's full table only has 2 electrons. That's how many electrons can fit in the first ring of an electron shell, so that's how many hydrogen is going to have. When we draw it out, these are making single bonds, so we just put these dashes, and we don't draw the other electrons. That's the line structure. And the name is hydrogen sulfide. So let's look at problem number 2, BR2. So again, first we want to start by putting our electrons around the table by looking at how many electrons it has in its valence shell. Bromine is here in column 7, which means it has 7 valence electrons. So I'm going to draw my first bromine with 7 electrons. There's its 7. I'm going to draw my first bromine with 7 valence electrons. That means 3 sets are going to be paired up and 1 will be on its own. And I'm going to draw a second bromine in the same fashion but with X's. And you see here there's room on each of the bromines for 1 more electron, so they're going to come together and share. So now we have Br2. Br2 is a diatomic, a pure diatomic element, which means that the name of this is bromine. And we draw the line structure, which is a line between them. So this compound creates a covalent bond. So the last one we're going to look at is CaO. So the first thing we need to determine is whether or not this can form a covalent bond. We have a metal and a non-metal, which should say to you, this makes an ionic bond, which means we need to draw the bubble structure of it instead of a covalent bond. It's not going to share electrons because these atoms are charged. So they are ions. So we have calcium, which has a 2+ charge, and we have oxygen, which has a 2- charge. Together, those make a neutral salt. And we can expand our lattice by adding more in every direction. And this salt is called calcium oxide. Change the ending to -ide.